alternative 3 was is kind of a green stormwater infrastructure where those hatched, kind of the red hatched is a permeable pavement potential of where the water could infiltrate, increase the infiltration in these, for these roads, instead of making them all impervious. So this is just kind of a sample set of what the of this one area looked like.
I'm going to stop now. Does anyone have any questions right now? Should we continue?
Okay. So then out of this next table, this is that top 9 flood areas, and then the top 6 out of that 9 were moved essentially to the next level, the highest priority alternatives. And what that means is, we took those stick figure graphics, those conceptual, and we went the next step and looked at 15% plans and cost estimates, and dug into them and a little bit more. And what is the benefit cost analysis? So we did that and proposed condition and modeling on those 6, and that's shown here. This is an example of the cost benefit analysis. This is kind of standard by FEMA. Does this to rank their projects as well. They look at number of properties impacted, how many, the population, costs, so forth, and the benefit cost ratio. So that was completed, and this is for, that one we were looking at is area A on your map. So that, and this is example of the kind of the 15% plans, also of area A, which is kind of the Invergordon corridor area just south of Indian Bend Wash there on the map. So the graphic on the screen is just one page of it all, and this is the roundabout at Invergordon and Northern Avenue. So this alternative is another storm drain pipe in the roadway with inlets capturing the flow. This map is also of area A. It shows Invergordon's north-south there, and Northern on the east-west road on the south. These colors, the blues, the yellows, this shows the areas benefited if that white and black dashed line, which is the storm drain, was put in place. Those blues and yellows are where the flow depths are reduced downstream of the project. Okay, now getting to the end here. So the master plan also includes grant funding opportunities. Some of these, which the town is very familiar with already, as they've used some of these, specifically the ones at the top. These are flood control of the District of Maricopa County, different grants, the small project assistant program, which I believe was used along Doubletree Ranch a few years ago for small infrastructure improvements, and then the capital improvement program, which is being utilized for the Mockingbird project. So those are obvious opportunities, and then other federal opportunities include FEMA, HUD, EPA, Army Corps, and so forth. Okay, so here is the table of the project prioritization from the highest area. The left column shows the different areas and the different benefits, the cost, benefit cost, and the project considerations. Ratio, benefit cost ratio. Yep. Yeah, so the key takeaways here. So from this townwide flood hazard model. You get the modeling that can be used to help regulate development, design, and it also can be utilized to design stormwater improvements. It helps assess these locations of where there's high building inundation, high erosion sedimentation potential, vehicular hazards. There's been identified 19 flood-prone areas. It's developed project alternatives for 9 of these, and then further developed 15% plans, costs, benefit costs for 6 out of the 9. And I've identified local and federal grant opportunities and prioritization considerations. So with that, welcome any questions.
Thank you, Andrew. Appreciate that. Shar, thank you for the presentation. I open up to the council for questions or comments. Councilmember LaBelle.
Thanks, everybody, and thanks for my reading material. We kind of keep that forever.
Yeah.
So thank you. I do appreciate it. Couple of questions. To what extent, and I'm going to give the example of Area E, where there is a discrepancy in cost of $14.9 million for alternative 1, to obviously alternative 3, $1.4 million. Now, I'm going to just be frank, I'm a big fan of anything more natural, permeable pavement, bioswales, anything that's actually going to allow the rainwater to, trickle back into the groundwater aquifers. But maybe in conjunction with, the concrete sewer lines, how much do you guys do bioswale or more green aside from permeable, and how much room is there in this process as we move along? Because it's going to be obviously ongoing and dynamic, from what I hear. How much do you see that other municipalities pulling this in also? And also, what do you think would be the difference in the channeling of the flooding or the water between those two alternatives? I mean, how much less impact is it going to have to use the more natural approach?
So the first question, I can take that.
Yeah.
So the bioswale, as far as how the potential of using that type of GSI, bioswales will require some land, of course, within the right of way.
Okay.
Yeah, so that's one thing.
No, understood.
Okay.
So that's why it's probably not in here, because that
Exactly.
was part of our, okay?
Yes. But we've looked at it, so. And then the other question was the one.
Yeah, about the impact of each one of these.
The difference between the permeable pavement then, so let's take bioswales out of the picture. If we're at alternative 3 to alternative 1, what is the effect on how you feel that would move that water out of there? And the sediment question also.
Yeah, so alternatives 1 and 2 would definitely have a bigger impact in removing flow off from the roads and private property. So if you kind of going back to that benefit cost, where the benefit is reducing the flooding downstream and so forth, the benefits of the top 2 would be higher.
Significantly?
Than the number 3? Yeah, significantly higher. Yeah. Number 3, but the costs are also significant,
Yeah.
as you can see, right? Number 3 is, it does help it, right? Because for all the things you mentioned, promoting more water into the ground takes less off the surface, right? But the rate of which the water trickles into the ground versus the rate that the rain falls on the ground is when there's more falling on the ground and it runs off, right? So, for example, like last Saturday, as we all experienced, I looked at a few gauges. It was about just under an inch of rain in less than 30 minutes. So the ground percolation just can't handle it.
Okay.
And that's where you get the washes filling up quickly, running off very rapidly. The permeable pavement, though, would help in like when we were walking in here, the drizzle, right?
Right.
That rate is so much lower that it has more opportunity to get into. So the less, it would help more with the nuisance flooding.
That's what I was going to say. Would there be a use for that more with the moderate or nuisance areas that we could mitigate the cost and maybe use some permeable pavement when it's ready, when that area is ready to be repaved? And would there also be a possible hybrid solution with some of these? Maybe we do a 2 and a 3